All right, guys, today we are doing geometric sum of sequences, which is also called series, okay? So we are going to add up and find the sum of a bunch of geometric terms, meaning they're being multiplied. So at the top of worksheet 6, you should have this. A geometric sequence is a sequence in which each term after the first one is the product of the preceding term. So a sub 1 is first term. You are multiplying with a common ratio r, what you're multiplying by, and remember r is often really dividing if it's a fraction that you're multiplying by. Therefore, to find the common ratio, divide any term by the previous term. Any nth term can be calculated by this formula, which is on our reference sheet, okay? And r, if you just always practice putting r in parentheses, it will be best, including the formulas we're going to learn today. One more thing, what does n stand for in this? Or any formula, n stands for the term number, okay? When we have terms between two non-consecutive terms of a geometric sequence, they're called geometric means. Just like with arithmetic means, they're basically saying there's some missing terms. 2, 3, 4, 5 missing terms that we have to find, okay? Everybody good? All right. The nth term of a geometric sequence, you already have this on your sheet, on your reference sheet. It says, remember that if a sequence is not arithmetic, it doesn't necessarily mean it's geometric. Okay, someone tell me the difference between the two quick. Arithmetic means you're doing what? Adding or subtracting something to get the next term every time. And geometric means you are, it basically means you're always multiplying, but we could look at it as multiplying or dividing because it could be a fraction, okay? But there are also sequences out there that are neither. Does everybody understand that? Okay? Where maybe you add 2 and then you multiply by 2, and then you add 2 and then you multiply by 2. That's a pattern, doesn't mean it's arithmetic or geometric. All right, find the 7th term of the geometric sequence. So they're telling us that they are multiplying by something. So we can take any term, divide it by the previous term, and that will give us r is -3. To find the 7th term, we could find the 6th term, okay? But the general form, remember, for geometric is this. So to find the 7th term, we can say the first term, which was 8, is multiplied by -3, 7 minus 1 times. If you do not put parentheses around the -3, you will get this one wrong. Okay, it's just always best practice to use parentheses around the r. 8 times -3 to the 6th. Somebody else get 5832? Okay. Everybody okay? That was not new, right? You're supposed to already know how to do that. That was just finding a term. Eventually today we're going to talk about sums, but I think first we're going to talk about some missing terms. Okay, 2 missing geometric means between 6 and 162. We have done this as well, we just didn't call them geometric means. If there's 2 missing terms in here, how many times did they multiply by r? Once, twice, 3 times, okay? So we could also say this is term 1, 2, 3, and term 4. So we could say to get to the 4th term, you would take the first term times r to the 4 minus 1. Well, we know this is 162. We know this is 6. We don't know r, but we multiplied 3 times. This is where that's coming from. I usually go directly to this. I don't start by thinking about that whole fancy formula. I just say, oh, look, they multiplied 6 by r 3 times, got 162. All right, if we divide by 6, does that come out nice? 27? And then what do? We either cube root, or my preference is to do 27 to the 1/3 power, just because I hate having to find that cube root thing, okay? So it's under math. If you want to find the cube root, it's number 4 there, but it's the same as saying to the 1/3 power. Now, if you have an older calculator, you would have to put the 1/3 power in parentheses if you had a really old calculator, so it's a little more painful, but everybody good that it's 3? Is that the answer to the question? We need to find those 2 missing terms. So if we say r is 3, then 6 times 3 would give us 18, and 18 times 3, 54, guys? Did I do that right? Okay. So 6 times 3 was 18, and then 18 times 3 became 54. And it should check. If you do times 3, it should give you 162. So I'm just showing you that these are self-checking. If you don't get the right answer on the other end, then you did something wrong. All right, find the first term. Okay, so really we're not using any fancy formula yet. They give us the 6th term. So what would the formula be for 6th term? First term times r, how many times? 6 minus 1, or 5 times. Okay, so what goes in for a sub 6? 0.1, we don't know a sub 1, so we're supposed to find. 0.2 is r, and 6 minus 1 is 5 times. What are we going to do to solve that? Yeah, we could just do 0.2 to the 5th power, but what are we going to have to do to get rid of it? Divide. So I'm thinking let's just make this divided by 0 and do it all at once. So a sub 1 is 0.1 divided by 0.2 to the 5th. 312.5, anybody else? Would be the first term. Okay, all of these are things that I will ask you on the quiz. I will ask you on the quiz to find a, like, 7th term, okay? I will ask you on the quiz to find geometric means. I will ask you on the quiz to go back and find the first term. All right, we're going to do a little more geometric mean practice. This time it says there's 7 missing terms, or 3, I can read, 3 missing terms between 7 and 567. Now, do you want me to write it in a fancy way, or are you just okay with saying that means 7 was multiplied by r how many times, guys? 1, 2, 3, 4 times? Okay, because if you counted, this is the 5th term. All right, so if I divide by 7, I think I get 81, don't I? And then you can either do the 4th root, which would be, again, under that math, or I would prefer 81 to the 1/4 power. I guess I'll show with that button again if you need it. It's under math, it's choice 5. You'd say the 4th root of 81. Should be 3, I think. Okay, so we found r is 3. Then we just go back. What's 7 times 3, guys? 21 times 3. Times 3, 189. And then times 3, does it work? Okay. That's always the check, is that last one. All right, I think we got that guy down. All right, that brings us to the formula that's new today. This is on your reference sheet, okay? This is the way the book writes it. This is the way Delta Math does it. Do you see what they did? They just distributed the A sub 1 to the top. Okay, it's weird. Either one is fine. I will probably use this one because I don't want to type A sub 1 twice. But in both cases, it is really best to put R always in an extra set of parentheses. So did I put it like this on your notes somewhere? Okay. Please, please, please use this idea of always putting R in parentheses. You can put the R in the denominator in parentheses as well, but you have to put the top one if it's a negative or a fraction. You want to put the R when it's to the power for sure in parentheses. Okay. Then there's another formula here, but we'll get to that one if we get to an infinite geometric series. All right. Geometric series is the sum of terms of a geometric sequence. So this is just new vocabulary. Just means we're going to add up. Sometimes that'll be literally written with plus signs in between. You can use a formula to find that sum, or it's called a partial sum of an infinite geometric series. All right. If you know that first term, and this should say ratio, not ration. If you know the first term and the R value, you can use this formula. Type carefully. If it's an infinite geometric series, then we'll talk about those in a second. Good news. Remember with arithmetic sequences, you had to know the first term and the last term? You don't have to know the last term for this guy, okay? We don't have to know the last term. You just put in the formula. So find the sum of the first 12 terms. It tells us it's geometric. It's written as a series with plus signs in between. You have to be careful. My eyeballs went to this and said, oh, we're adding 1.5. But this is geometric, so we're multiplying. So can somebody do 7.5 divided by 6? We're multiplying. Our R is 1.25 or 5/4 if you wanted to do a fraction. We want the sum of 12 terms. Okay, so this is our fancy new formula. You would need the first, I'm going to write it out. The first term times 1 minus R. Notice it's to the n, not the n minus 1 when you're finding the sum, okay? And then you divide by 1 minus, and I'm going to put that extra parenthesis in there. All right, so for this question, our first term was what, 6? So we're going to have 6 times 1 minus 1.25 to the 12th divided by 1 minus, and you really don't need parentheses if it's not to a power, so I'll skip one extra set there. All right. 6 times 1 minus 1.25 to the, whoops, how did I get 2 minuses? To the 12th, is that right, guys? Close your parentheses. You do have to arrow out of the little box in this mode, this kind of calculator operating system. And then it's 1 minus 1.25. Now, they want an exact answer. It either means you have to write down the whole decimal, or better yet, you do the math enter to get a fraction. Ooh, and this one is not happy. I don't know if I'd put it in as 5/4. Ugh. We're just going to write this down and be done. for this one. It was given to us as decimals. I was very careful on the quiz. Like if we had changed this to the sum of the first 10, it might have given us a fraction. I double checked on the quiz that they would all switch to a fraction. Let me see if I go back up here. Have I said we only want the sum of the first 10 or 9 or 8? Sometimes if you don't go out so far, it's more prone to give you that. I don't know if that's going to go either though. Nope. All right, we'll keep going and I'll show you some that. Oh, we're going to throw in new one right away. This is the other formula that actually isn't on the quiz. If possible, find the sum of the geometric series. What is R here? Take any term and divide it by the previous term. 0.2. Okay? If R is, the absolute value of R is less than 1, okay, positive or negative number less than 1, the series is going to converge, which means it is approaching a certain number. In this case, it's going to approach 0, and therefore we can say what the sum would approach as well. Let's think about this for a minute. Let me just show you on the calculator. Clear. It was 0.2, guys. 40 times 0.2, enter, times 0.2, enter. Let me show you what's happening here. If I keep pushing enter, what is this number getting very close to? Do you recognize that? Scientific notation is getting really close to 0, yes? So if we keep adding little pieces that are tinier and tinier and tinier onto this, it's going to approach a limited value because you're basically adding 0 after a while. So to find that, you take the first term over 1 minus r, and that's it. So it's 40 over, you'd need parentheses, 1 minus, we're not doing a power, so we could just do that. Put the 0.2. But you would need parentheses around the whole divisor. 40 divided by 1 minus 0.2, which is 0.8. 550? I was going to say 550. Okay. Again, if I go back here, up my list a ways, see how it started at 40 was our first term right here. Then we'd add 8, we're up to 48. We'd add 1.6, so we're at 49.6. And then this would make it 49.392. And you're adding little teeny tiny pieces. Do you see why it's eventually approaching 50? Okay. It's a very interesting concept. It's not something I put on the quiz, just so you know. All right. The sum of the first 7. So we just need the first 7. So we're doing the sum through 7. What's the formula? What are they doing every time here? They're not adding, multiplying by positive 4. Is everybody good? Negative 1 times 4, negative 4 times 4, negative 16. Okay. Can I just ask you a question? Is that going to approach a certain value? If I keep multiplying by negative 4, what's going to happen to those numbers? Or by 4, sorry. They would get bigger, except it's negative, so they're really going to get very, very negative, right? So it's, if I kept adding more and more and more negative numbers, it would actually approach like negative infinity or whatever. It's not going to approach a single value, but we want the sum of only the first 7 terms. So the formula is a sub 1 times 1 minus r to the n all over 1 minus r. So here it's going to be negative 1 is our first term times 1 minus 4 to the n. What's n again? 7, yes. Because it's not n minus 1, it's just n. Divided by 1 minus 4. Negative 1 was the first term. 1 minus 4 to the 7th. Arrow to the right, close that parenthesis, and then divided by 1 minus 4. Anybody get that lovely number? Okay, I gotta tell you, the trouble with this comes when r is less than 1 or when r is negative, because students don't type it in right. They can write it down right and still not type it in right. Negative 5461, okay. All right, are we coming up on some where we're doing something crazy? Find the sum of the first 16 terms. Oh, what is this called? Does anybody know what this is called? What kind of a form is this? It's not explicit, it is, anybody remember that word? Recursive. Okay, and it means they tell us the first term, and then they tell us you're multiplying by negative 2. So what would the next term be, guys? 1 plus negative 2. Times. 1 times negative 2 would be negative 2. Times negative 2 would be positive 4. Times negative 2 would be negative 8. Now, if you start adding those up, weird things are going to happen, right? Because some are positive and some are negative. So we are supposed to find the sum of the first 16 terms. What's that going to look like? Help me with the formula, guys. First term, 1 minus, what's r? R is negative 2. This is one of those where you have to put that in there, the parentheses, to the power of 16, all divided by 1 minus negative 2. Now, I'm going to show you this and talk about this, and somebody's still going to do it on the quiz. If you want to make this minus a negative into a plus positive, you can. Can you do it here? No, because of the exponent power. Don't mess with this. Type it in just like this, okay? Cannot stress that enough. So it was 1 times 1 minus negative 4 to the, make sure you're using minuses and negatives appropriately. It was negative 2. Thank you. And what was our R? 12? 16, see? There's a reason I'm retiring. Can't remember anything. Divided by 1 minus negative 2. Okay, the calculator will take care of the fact that that becomes plus positive and this one doesn't. Negative 21845. Okay. Should I tell you what you get if you take those parentheses out? Because it'll be the wrong answer, I guarantee it. If you don't do the extra parentheses, not the same, right? Okay. Find the sum of the first 20 terms. This is an explicit equation. It's clearly arithmetic, okay? We could find any term by putting in the term number. So if we wanted to find the 20th term, we could find it. But do we need the 20th term? To use this formula, the sum of the first 20 terms, all I need is what? All I need is term 1 and r. Now, if you know the generic form, you probably recognize term 1 and r, but in case you don't, if you put in a 1, you would find term 1. Well, anything to the 0 would be 1, so the first term should just be 2. And then what are you multiplying by over and over according to this? Yeah, 1.05 is our R value, because this goes a sub 1 times r to the n minus 1 equals a sub n. That's the formula we talked about first thing today. So 2 times 1 minus 1.05 to the, what are we doing, 20 terms? Over 1 minus 1.05. All right, I'm not going to do it on that calculator because it takes me twice as much time. 2 times 1 minus 1.05 to the 20th divided by 1 minus 1.05. And it's a ugly decimal that doesn't turn into a fraction, yes? All right, so I'm thinking this is not very exact, because I'm sure they rounded at the end. Often the quiz will say exact. It depends what you're doing. This is a kind of equation that would apply for like, I buy a stock for $2 and it's raising at 5% per year. What is the sum of my earnings after 20 years? So then it would be appropriate to say $66.13, okay? So if I wanted an exact answer on the quiz, I made sure it said exact, and I made sure that it was something the calculator would give you a more exact answer. Okay, do you remember how to do this? Everybody in here said they had a calculator that could do this, right? Where's the button? Under math, arrow up or down to find that summation. You can use any variable. Did this one say the first 11 terms? So 1 through 11. And everything has to go in the box, remember. So don't put a number out in front of these parentheses. So it's 5 parenthesis 1.06 to the n minus 1. And it's got to all be inside of those parentheses they gave you. Questions? Does anybody need to know how to do it on the old calculator? I could show you real quick. It's, sorry, that's the wrong place. Under list, it's the sum, and you go back there of the sequence, and you put in, I already forgot what it said, guys. 5 times 1.06 to the n minus 1. Ugh, I think you'd need parentheses here. Oh, this was a waste of my time. What did we do? Terms 1 through what? 11? Same answer. After half hour of finding gross buttons. Okay. These are supposed to be infinite geometric series. I am not going to ask you one like this on a quiz, but let's do these real quick. Can you tell what they're multiplying by on number 9? What is R? 3/8. Remember, infinite geometric series only works if the absolute value of R is less than 1. Is this less than 1? Yes. And then the formula is very simple. Is it a sub 1? I already forgot the formula. A sub 1 divided by 1 minus R? Yes. Here's the formula. So all we have to do is find the first term. Sorry, where did my pens go? What happened? There we go. Yikes. It's a sub 1 over 1 minus r. What's a sub 1? Well, put in a 1, you'd have 3/8 to the 0, which is 1 times 13. So 13 is the first term, and then down here we have 1 minus 3/8. So what does that give you? 13 divided by 5/8 is 13 times 8 divided by 5. I don't know what that is. Was it 3/8? The R? 20.8? All right, let's do one more for fun here. What are they multiplying by here? This one we should eyeball. $10. You give your sister half, you're down to 5. You give your sister half again, you're down to 2.5, right? So R is 1/2. Is that an infinite geometric series that we can find the sum of? As long as R is absolute value of R is less than 1, yes. So term 1 divided by 1 minus R. I think that one's going to be 20. Somebody type in? Yep. All right. Like I said, not on the quiz, but, and I'm not even sure I put it in Delta Math tonight. I know it's on some of the review worksheets. It's a good math team thing to know. Each year, the value of a car depreciates by 18%. If you bought a car for $32,000 in 2019, what will its value be in 2024? All right, so this gets a little, two things happen. Students struggle with how many times does it depreciate, but they also struggle with the fact that, remember how we have to do this back in the exponential chapter? If something is decreasing by 18%, you don't multiply by 0.18. You do 1 minus 0.18, because 72% remains. Does this sound familiar? If something is growing by 5% or 6%, that looks like this, right? 1.06. So that's the first thing students struggle with. This is going to be our R value. But if it started at 32,000 and it multiplied by 0.72, we need to decide if we're going to do the number of years or the number of years minus 1. We have to kind of think about this. If we call this term 1, if we take 2019 minus 2024, how many years is that? That's 5 years. Okay, you bought it new. By the end of 2019, depending when you bought it, when it turned over to 2020, that would be the first year it depreciated. 21, 22, 23, 24. So it really did depreciate 5 times. So I think we're supposed to go with a 5 here, not a 5 minus 1. Did I subtract wrong? Was anybody going to tell me? This is not 0.72, isn't it 0.82? Yes? Hofbauer can't subtract. Haven't you not learned this yet? All right, so somebody do this. I have down that it comes out to 11,864 if I round to the nearest dollar. Okay. The one on the quiz I worded so that you would be clear whether it's to the 5th or to the 5 minus 1, okay? And we'll review it some more. But you have to be a little bit careful of that in the Delta Math. There are some application problems. Rent an apartment that costs $900 a month, but the rent goes up 7.5% per year. What would you be the rent of the apartment during the 8th year? So during the 8th year, I'm thinking the raise has only gone up 7 times. So we're going to use 8 minus 1. And it started at 900. Now this is asking for the rent, not the total that you've paid in rent, okay? But how do you say goes up by 7%, 7.5%? Yes, 100% plus 7.5% would be 107.5. You move the decimal twice, we're gonna have 1.075 in here. All right, type that in. I think you're not gonna be very happy with your rent if you thought you were gonna only pay $900 forever. $1493.14. Okay. Now remember, that was finding term 7, which was the first year the rent was that amount, and then during the 8th year. So not the sum of those. An employee agreed to a salary plan where his annual salary increases by 4.5% each year. He earned $50,000 for his 10th year of work. What was his first year's pay? So the first year was multiplied by some R, 10 minus 1 times to get to the 10th term. Does that seem right, guys? For his 10th year of work, would he have only gotten 9 raises? That seems right to me. So what are we going to put into those? What was his first year? Isn't that what we're trying to find, isn't it? R, what's R? Be careful. 104.5. Does everybody understand? He's not getting, if you multiplied by 0.045, his salary would go shrinking down a lot, right? You want it to keep everything plus 4.5%. That's why it's 104.5. So you move it over twice to get rid of this percent symbol, and you get 1.045. To the 10 minus 1 is 9 raises. And that's when it became this 50,081.41 that I can't squeeze in there. So what are we going to do? Yeah, so we're just going to get rid of this multiplication of this disgusting thing and by dividing it, right? All right, so grab your calculator. I don't want to type that mess in on that fancy calculator. I got kind of a weird answer, but did anybody else get 33,700 and then like 0.002, or did I type something wrong? Okay, so I'm thinking this was his starting salary. It's just because they had to round to the nearest penny that it came out with some junk at the end there. To the nearest dollar, how much did he earn for his 10 years of work? What is this asking for? Yes, the sum of the first 10 years. The formula for that is a sub 1 times 1 minus r to the n, not the n minus 1, over 1 minus r. So we will have 33,700 times 1 minus, what's r? 1.045 to the 10th over 1 minus 1.045. Okay, please be typing. I cannot stress enough that if you are not getting this, I need to help you figure out what you're typing wrong now. And my issue is going to be remembering to arrow to the right to get out of that little exponent box. Let's see if I can move this answer. Went with this question. Which was the answer to part A. Anybody get 414,112 and 66 roughly? No? Yes? Anybody not getting that? I'll stop the video and come help you. We good? Are you going to remember all those parentheses on your own? All right, I'm going to skip this one. Looks long and complicated, and I think we should be done for the day. I could do it as a warm-up tomorrow or something, but Delta Math, geometric sequences and series, some are applications, some just ask you to find the sequence or the first term or the whatever, and some ask you to actually find the total. So read carefully. Tomorrow we're finally going to learn how to put our calculator in sequence mode.